So the problem situation for this subject was to create a multiple linear regression, which is a statistical technique that predicts the outcome of a dependent variable by considering two or more independent variables. This is important because it allows to estimate an association between the variables and it gives the opportunity to adjust them. The purpose of this video is to demonstrate how the model fits a multiple linear regression and to interpret the relevant statistics in order to achieve what we want. So the problem situation was to predict the selling price of a Camaro brand, where data was given, which was the age, the mileage, and the conditions of the car. The conditions were if they were in good state or not, and if they had owners. This data will help us create our regression analysis and graphs. So the first graph that is shown in the video is the graph of age and price. This graph shows the age and the mileage as independent variables and the price as the dependent variable. To start making assumptions and process the data we had to start modeling the graphs to have a visual content, and then we obtained the regression statistics which showed important data that could help us get the assumptions and the correct conclusions. The program we used was Excel, and we started selecting the data we had. We first made a graph comparing one independent variable, which was in one case the age and in the other case the mileage, against the price. In the scatter plot of age and price, we got a coefficient of determination of 75% of variation in the price, which was explained by age, which we considered sufficient given the fact that we were trying to reach 100% of variance percentage. The correlation between both variables was of minus 0.87, which means that it was a negatively strong correlation because of a value that we got. Now, in the mileage and price graph, the R-square value was of 73% of variations price explained by the mileage. This percentage was lower than the other graph, and a lot of unknown information was unexplained. Regarding the correlation of the variables, the number obtained was minus 0.85, which can be considered as well linear correlation negatively strong. In other words, this is explaining that every time the independent variable, which is the mileage, increases, the dependent variable, which is the price, will decrease because of their correlation. The confidence interval used for all the graphs was of 95%, which is considered a high confidence level. For the last two graphs, which are taking into consideration two or more variables, we could see that the estimated price was more accurate and it was more explained. We could see that the adjusted R-square was of 0.87, which allows us to know the variability of the price taking into consideration all the variables. Said in other words, this means that 87% of the factors that affect the price are explained. As a conclusion, we can say that the linear regression model is a good option because it explains and estimates the variability in the price, taking into account all the variables, and even though it contains certain error, it is really close to the price we wanted to achieve.